It's a lot of Ghana TV. Welcome. 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 Welcome, boys and girls. Welcome, boys and girls. You can share the live. 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 You can share the live, boys and girls. You can share the live. Can we give just people to join, time to join in? Let's say about 5 minutes. 5 minutes. Now it's 8 o'clock. We can start at 5 past. Let's just give them about 5 minutes. You can tap the screen, guys. You can tap the screen, share the live. You can tap the screen, you can share the live, guys. We are about to start. We'll start in about 5 minutes time. 5 minutes time. Now it's 8 o'clock, a minute past. Am I muted? Is it fine now? Am I audible? Am I audible enough, guys? Am I audible enough? You can give me a thumbs up if you can hear me. Give me a thumbs up. I'm seeing Onka is saying unmute. Can you hear me? Say we cannot hear you. We cannot hear you. All right, let me fix the sound. We cannot hear you. Let me see. All right, I see. Can you hear me now? Can you hear me now? Follow slow. Can you hear me now? Can you confirm? Can you hear me now? Chuma, Onka, can you hear me now? Can you hear me now? Say we can't hear you. Can you hear me? Can you hear me now? 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 Can you confirm if you can hear me now? We cannot hear you. Okay. We just want to give people time to join in. 5 past, we are starting. We can't hear you. How is that possible? We can't hear you. Can you hear me now? Just YouTube. To go to YouTube, you will hear him. There's no sound. How is that possible? Anything? Can you hear me now? Can you hear me now, guys? Can you hear me now, guys? Can you confirm? I'm hearing people on YouTube. They're saying they can hear me. I want to start now at 5 past. 5 past, we're starting. Can you hear me now? Can you confirm? Can you hear me now? Please confirm if you can hear me. I can hear him on YouTube. Can you hear me now? Yes, you can hear me. That's it. I think we can start now. Can you hear me now? Thank you so much. So welcome, guys. Welcome, guys. Welcome, guys. So here's what we are going to do, guys. What I want us to do today, guys, I don't want us to rush. I'm going to analyze. You can see the sketch that is being projected now. I'm going to analyze it with you. You give me a chance to analyze it. After I've analyzed and you understand everything, then we can move on to the question. We are going to start off with a short question. So that's what I'm going to do. I'm going to analyze this sketch that we have. Let's start now. So it reads, refer to the sketch below of synoptic weather map. Let me just try to highlight as well of synoptic weather map. Of course, synoptic weather map. Complete the statements in column A with the options in column B, page 4. Write only Y or Z next to the question number. So what we are going to do, guys, I'm going to analyze this diagram that we have first. Let's get the concept first. That's what we want. We want to get the concept to understand what is this all about. Okay, so guys, we have been told that this is a synoptic weather map. So our analysis is going to focus on these things, okay? Our analysis, we are saying now, analysis first. We are going to do an analysis. That's what we want to do first. Number one, we want to determine the season. Which season it is? Okay, which season it is. So how do we determine whether it's winter or it's summer? That is the first thing that we have to do, guys. So this diagram is showing you the weather condition. You can see here, unstable weather condition. You can see your low pressure, which is more like your thermal low in the interior. So this already is telling you that this is summer. So this is summer, okay? Why are we saying it's summer? Number one, what we have got low pressure, okay? Low pressure in the interior, low pressure in the interior or inland. Let me just say inland, just to make your life easier. Low pressure inland. What else do we have? Look at the position. Look at the position of a higher pressure system. Position of higher pressure system. Position of higher pressure system. Can you see the position of higher pressure system? They are further south, okay? They are in the southerly position. Southerly position, okay? They are in the southerly position. All right. They are in the southerly position, okay? That's something that we can pick. So we are saying number one is summer. You can see here an L, low pressure in the interior, which is our thermal low. Okay, that's what we have. Okay, then what else? Low pressure in the interior, position of our high pressure system. Remember our South Atlantic high and our South Indian high, they change their position with the shifting of the ITCZ. Okay, southerly position. Why are they in the southerly position? 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 Okay, southerly position. Okay, okay. So the reason is the shifting of the ITCZ, shifting of the intertropical convergence zone, intertropical convergence zone, which is our ITCZ. So ITCZ in summer, it shifted to the southern hemisphere. So when it shifts to the southern hemisphere, it means our two high pressure system, that is our South Atlantic high and our South Indian high, they also move further south. That's basically what we are saying. So you can see that it is summer by looking, number one, there is an L in the interior. This L, which is low pressure, which can also be an thermal low, heat low, is the same thing. It's in the interior. Number two, the position of high pressure system, southerly position. Why are they in the southerly position? Because of the shifting of the intertropical convergence zone. That is the ITCZ is in the southern hemisphere. Okay, it's in the southern hemisphere now. That's why our South Atlantic and our South Indian high have moved further south. So I'm supporting why I'm saying it is summer. That's what I'm doing now. So that's what I can pick from this. What else do we have? We can also look at our cold front. Cold front, okay? Cold front is further south, okay? Is further south. Is further south, okay? You can see it is further south. It is further south. Our cold front is further south. You can see ITCZ is the intertropical convergence zone. That is your ITCZ, intertropical convergence zone. It is a low pressure belt. It is a low pressure belt, also known as the equatorial low. That is grade 11 stuff now. ITCZ is the intertropical convergence zone, also known as the equatorial low. Okay. So cold front is further south. You can see where our cold front is. It's far away from Cape Town. You can see here. It's further south because of this one. It has got a blocking effect, our South Atlantic high. So it cannot affect weather in the interior. That's why you see our cold front is far away. That's one thing you can also look at, okay? What else can you also support that it's summer? We have got unstable weather conditions here. Unstable weather conditions. That's something that we have. Unstable weather conditions. We are looking at unstable weather conditions. Unstable weather conditions. Okay, which means you can see there's an overcast there. You can see, look at also at the comma, look at the temperature as well. The temperature as well. That's something that you can also look at. Here I'm trying to support that it is summer. That's what I'm trying to do. So that's what we have. Analysis season, it's summer. Low pressure in inland. Position of a high pressure system is in the southerly position. Why are they in the southerly position? Because of the shifting of our intertropical convergence zone. That is ITCZ. It's a low pressure system. It's a low pressure zone. Okay, it has shifted further south. That's why we have got our L here in the southern hemisphere. Okay, so cold front is further south. This is our cold front here. It's further south. Why? This one has got a blocking effect, our South Atlantic high. So it is further south. It's not going to affect weather in summer. That's why here in Cape Town, they do not receive rain in summer. Why? Because of the region of our South Atlantic high. Okay? Then unstable weather condition, you can see the overcast, the temperatures, what is happening here. Okay. So what else can we pick from this? You can also look at from the, I'm just analyzing what is on the diagram, where we have got isobus close to each other. Isobus close to each other. We say there is a what? A steeper pressure gradient. Steeper pressure gradient. Steeper pressure gradient. Pressure gradient. Okay? Pressure gradient, which resembles what? Strong winds. Okay, which resembles what? Strong winds. That's what it so strong winds, that's what it resembles. You can see here at D we have got isobars. These are line that shows area of equal pressure. This is what we are saying. They are very close to each other. It shows a steeper pressure gradient. They are very close to each other. Okay, what else can we also see? If you can check here from A to A, we can see there is elongation of isobars. Elongation of isobars, which we call ridging. Elongation of isobars, we call it ridging. Here, from A to A, that is elongation of isobars, we call it ridging. That is elongation of isobars. We call it ridging. Okay. Remember, our wind, it moves from high to low pressure. So elongation of ridging of our isobars. Here we have got our high pressure. That is what we call elongation of ridging. You find this way we have got our high pressure. So that is ridging there. What else can we pick? We have got the weather station model as well. The weather station models that we have here. Okay, what do we have? You can see what we have here. The weather station model. What we have is to remember this. Of course, this is your 5 knots. You can see it's not starting at the end. 5 knots. Okay, 3/4 cloud cover, air temperature 30 degrees, then dew temperature, that is what? Your 18 degrees. These are some of the things that you're supposed to know. These are some of the things that you're supposed to what? To know as well. Then you can see also the wind direction. You can see also it's more of your southeast. That's basically what we are talking about. Southeast, okay, north, south, west, east. So that's more southeasterly winds. Okay. So these are some of the things that you can actually pick from this diagram. I don't know if you get what I'm trying to say. Then you can also pick your isobars. Isobars, okay, areas with equal pressure, okay, areas, okay, with equal pressure, okay, areas with equal pressure, okay. These are your isobars here. 1020 is 1020 millibars or hectopascals. Okay, hectopascals. So it's recorded in millibars or what we call hectopascals. Okay, hectopascals. That is the unit of measurement of our pressure. So everything that we have here, you can see is 1016. That is the isobars showing the pressure. Here you can see also 1014. So you also need to know what we call the isobaric interval. Isobaric interval. Okay, the difference in pressure between isobars. That is your isobaric interval. In most cases, it's 4 hectopascals. That is your isobaric interval, which means when you look at this from 1000 to 104, there's a difference of 4 millibars or 4 hectopascals. 4 millibars or 4 hectopascals. So that is the isobaric interval. They can give you 1000, then they can ask you what is the pressure at B, which means you just add 4, which means from 1000, 1004, 1008, and 1012. So that is your isobaric interval. What I'm doing, guys, I'm explaining the diagram first before we start with the question. That's what I'm trying to do, Sam Kellison. You can pay attention. If you want to add some notes, you can also do that. But I want you to understand the concept first before we start answering the question. That's what I'm trying to do. So what I'm doing here, I'm analyzing this diagram. I have picked up number 1, that the season that is shown here is what? Is summer. Why am I saying summer? Here I'm trying to support or to substantiate why I'm saying it's summer. Number 1, I've said there is a low pressure. Remember, if it's winter, which means there will be high pressure in the interior, which means our Kalahari will be very strong. Are we together? There will be too much subsidence. Okay. So don't worry, we'll get to the question paper, guys. I want you to understand first. Okay. So I've also talked about the position of a high pressure system. Okay. That is your South Atlantic high here and your South Indian high. They are in the southerly position. Why? Because they shift. They change their position with the shifting of the intertropical convergence zone. In summer, when the ITCZ is in the southern hemisphere, that's when they move further south. That's why you see they are in the southerly what? They are in the southerly position. They are in the southerly position. That's why you see here they are in the south position. Okay, south position. That's basically what I'm talking about. They are in the south position. That is your South Indian high. South Indian high. You can also look at this one. Is also in the southerly position. Okay, that is your South Atlantic high. That's basically what we are talking about. So they shift their position depending with the movement of the ITCZ, which is the intertropical convergence zone. Is a low pressure belt. It is also known as the equatorial low. Okay, that is your ITCZ. So we are saying now here we are supporting why it is. We are saying it's summer. Number 1, low pressure inlet L. This L. low pressure inland. Number 2, position of a high pressure system. The South Atlantic High is in the south position. It has moved further south because of the shifting of the ITCZ. Both of them, they shift further south. Then, what else? Cold front is further south. You can see your cold front here. Here is your cold front. Okay, cold. You look at the cold front position. Cold front position. Okay, is further south as well. Which means, why is it further south? Because the South Atlantic High has got a blocking effect. It ridges, so it means it's blocking high. It's blocking it from affecting the weather here in Cape Town. That's why in Cape Town, they do not receive rainfall in summer. Why? Because of the effect of movement of our high pressure system, which actually moves further south. That's basically what I'm talking about. Then the isobars are very close to each other, which means there's a steeper pressure gradient. I'm talking about this area now. Isobars here. Isobars are close to each other. Okay, I've said it's what? Steeper pressure gradient. Okay, pressure gradient. Okay, that's what I've said then. Then what else do we have? I've talked about the isobaric interval. Isobaric interval. Okay, interval, which is what? 4 hectopascals or 4 millibars. That's what I've talked about now, guys. So this is what we have from the explanation that I've given. I don't know if you understand. Do you understand the way I have analyzed this? Do you understand? Can you give me a thumbs up if you understand? Then we can move on to the questions. Do you understand the way I have analyzed this? Or if you've got some questions? Give me a thumbs up if you understand so that we can move on to the questions now. Because I want you to understand the diagram first before we start with the question. We don't want to rush things. We don't want to rush some Kelly, so thank you. Give me a thumbs up. Give me a thumbs up if you understand. I was just analyzing the diagram so that when we get to the question, it makes our life easier. Okay, so I can see you all understand my explanation from the diagram. Let's move on to the question now. Let's move on to the question now that you understand. Guys, we are not doing map work. Let's not mix things. Let's not mix things, please. All right. So our first question now is saying, the synoptic weather map illustrates typical. Is it summer or winter? From my explanation, is it summer or winter? Is it summer or winter? Give me the answer for 1.1.1. It's Z, of course, which means our answer there is what? Is Z. Thank you so much. Okay. Then number 2, it reads, are we all fine with number 1? 1.1.1? Sharp. Let's move on to number 2. I explained already the concept. Line AA represents a, what does line AA represent now? Let's go to the diagram. Line AA, yeah, that is here. That is a ridge, okay? It represents a ridge, okay? Okay. It represents a ridge, which is elongation of isobars, okay? Isobars, usually this is associated with the high pressure elongation of isobars. So this is what we call ridging, AA. Okay, sharp. Let's move on, which means our answer here is what? Is Y. Is Y. So a trough, guys, a trough, you find it on a low pressure. Oh. Our answer is Y there. Our answer is Y. So when you talk about a trough now, the trough that we have is elongation of isobars on a low pressure. A trough, elongation of isobars on a low pressure, but ridging is on a high pressure. That is the difference. So we are saying if it's a trough now, okay, a trough now, so that at least we have an idea. This is on a low pressure. Okay, it's on a low pressure, but it will also be elongation of isobars. It will also be elongation of isobars as well. Okay, so you have to know the difference between the two. So our answer here is Y. Our answer is Y. Let's move on to the next one. The air pressure reading at isobar B. 1.1.3, let's go. The air pressure reading at isobar B what will be the pressure reading here at isobar B? Remember the isobaric interval. This is 1000, 1004, 1008, which means here is, sorry, let me just try to, which means here is 1012. That will be the answer there, 1012. Let's go and check. Let's go and check, which means our answer here is what? Is Y. All right. Do we all understand? Do we all understand? Give me a thumbs up if you understand 1.1.3. Give me a thumbs up. Thumbs up if you understand 1.1.3, guys. I'm not here to confuse people. I'm not here to confuse people. I want to make sure you understand, guys. We are not rushing. Whatever we cover, I know you are going to master everything. Let's move on to 1.1.4. The air pressure gradient is steeper around the weather station at, right. So what you need to understand now is, here is saying the air pressure gradient is steeper. Let's go now and see where is the air pressure gradient steeper, where the isobars are close to each other. All right. Can you check here? I want you to check here. Can you check? Check here what is happening here. The isobars, they are very close, which shows a steeper gradient, which means our answer is what? D. Our answer is D. Let's go there. Our answer here is what? Is D. That is our answer here, which is Y. Okay. All right. Do you understand why I say it's Y? Are we together? That is why. Do you understand? Are we together? Give me a thumbs up, guys. I want people, let's communicate, guys. Let's communicate. Let's communicate. Let's communicate. Do you understand? Give me a thumbs up if you understand why I'm saying why. And if you disagree, let's talk about it. We are saying steeper pressure gradient, the isobars will be very close to each other. They're very good. These are the type of people that I want. All right. So when the isobars are very close to each other, it shows a steeper pressure gradient. Here, this is the weather station BD. The isobars are very close to each other, so it shows a steeper pressure gradient, which means they are stronger. When the isobars close to each other, steeper pressure gradient. So this station D has got a steeper pressure gradient. Are we together now, Kile and Nyasha Banks? Are we together now? So the isobars, when they are close to each other, isobars, they show areas of equal pressure. So if they are very close to each other, like what we are seeing here, it shows that there is a steeper pressure gradient. Steeper pressure gradient meaning strong winds. Okay, are we together there? Nyasha and Kile, give me a thumbs up if you understand now so that I can move on. Nyasha and Kile, give me a thumbs up if you understand so that I can move to the next person. Thank you, Nyasha. Kile. Thank you, Danko. So it means our answer there is D. Let's move on now. This one, I want you to pay attention, guys. I want you to pay attention here. This one is tricky. I want you to pay attention. The northeasterly wind that at Durban is influenced by. Okay, I'm going to the diagram now. The northeasterly wind is influenced by in Durban. Okay, let's go now. All right. Remember what happened here. This is a higher pressure system. Let me write something. This is a higher pressure system, which means in a higher pressure system, the circulation or wind movement, let me just try to write with them small letters. Circulation in the southern hemisphere is anti-clockwise. Anti-clockwise. So that's what happened here. So we are saying now, in the southern hemisphere, high pressure system, the circulation is anti-clockwise. So we are saying now, it's influenced by, remember, in what happens in summer is we have got from our South Indian high, northeast going towards the interior to where our moisture front is in an anti-clockwise. Same applies here, where we have got our South Atlantic high, it moves in an anti-clockwise towards the interior. Then they meet here, where we have got the moisture front. So northeast is affected by the anti-clockwise. Are you following? I want you to understand the concept first. So in an anti-clockwise direction, remember the northeast, which is warm and moist, coming from the South Indian high, going towards this is summer. So it is influenced by the anti-clockwise as it moves towards the interior, where here, where this one is, this is more of your moisture front here. So then it moves in an anti-clockwise towards the interior, that is from the South Indian high. This one as well, it moves in an anti-clockwise towards the interior, that is from the South Atlantic high. Then they meet in the interior here, where we have got your moisture front. So you are going to have something like this, okay? We are saying you are going to have something like this. This is where, all right, so it's not, it's okay, sharp. This is your moisture front here. So the question is saying, let me go back to the question. Maybe that's why you are a little bit confused. The question is saying the northeasterly wind at Durban is influenced by the circulation of air. Remember, this is a high pressure system. In short, let me not confuse you. High pressure system in the southern hemisphere, it moves in an anti-clockwise. That is the circulation. It's anti-clockwise. Remember, high pressure anti-clockwise, low pressure is clockwise. So the answer here on 1.1.5 is Y. Are you following? You understand lyrical? You understand? So your answer there is what? Is Y. That is your answer. All right? That is the answer there, Y. Okay. Do you all understand, guys? D is saying, I don't understand. So this is the basic, né? The circulation of our anticyclones and cyclones, okay? Anticyclones, which is high pressure in the southern hemisphere, they circulate in an anti-clockwise. They circulate in an anti-clockwise. That's what happened. That's basically what we are talking about. We are saying high pressure or okay, high pressure, okay? Let me write it here. High pressure in the southern hemisphere, in the southern hemisphere, then I'll say is anti-clockwise circulation. That's basically what I'm talking about, guys. High pressure in the southern hemisphere, anti-clockwise circulation. Then low pressure in the southern hemisphere, is clockwise circulation. That's what we are talking about, guys. This is what we are talking about. So here we are saying, now we have agreed that this is all right, let me go back. This is our summer. In summer, we have got the warm and moist northeast winds from the South Indian high. Then we have got the what here? The cold and dry southwest wind from the South Atlantic high. So here we are saying what is influencing here the circulation is your anti-clockwise, because it's a high pressure system from the South Indian high. Are you following now? Are you following now, guys? Give me a thumbs up if you understand now. Or I should go deeper. Are you following now, guys? Do you understand now so that we can move on? Thank you, Chuma. You said you understand. Thank you so much. Thank you so much, guys. I'm happy, guys, if you understand. I'm happy because I don't want to rush things. I don't want to confuse you at the same time. So the answer there is anti-clockwise. Thank you so much. Let's move on. The unstable weather conditions at weather C are due to the development of. So we are saying, remember when we were explaining this, remember, one of the characteristics that supports that it is summer, I said unstable weather conditions. Can you see here? Overcast temperature and everything here. So what is causing that unstable weather conditions? Let's go now and look at our options. Okay, the unstable weather condition. What is causing the unstable weather condition here? Moisture front. This is summer, guys. Moisture front. So our answer there is what? It's Z. That is our answer there. It's what? It's Z. Okay. Do we all understand? Do we all understand why we are saying is Z? Moisture front in the interior in summer. That is our moisture front. Okay, sharp. Thank you so much, thank you so much, guys. Let's microwave this paper. Let's cook it. Let's move on to 1.1.7. Which weather station illustrates the following changes? So what I want you to take note of, guys, here is which weather station illustrates the following changes in 24 hours. What you have to take note is the wind direction has to change to southwest. That's number one. Number two, the air temperature has to decrease by 6 degrees Celsius. Okay, let's go back to our, all right. So if we look at this, at F, if we reduce the air temperature, which is 30 minus 6, what will be the answer? It will be 24, isn't it? 30 minus 6, we get what? 24. We are saying this 30 that we have here, that is the air temperature. If we subtract 30 minus 6, we get 24. Let's look at what we have here. The easiest way. Can you see, guys? Your answer here is what? Is Z. Because our air temperature is what? 30. So our answer there is Z. We have just said 30 minus 6, then we get 24. That's how we got this 24. Are you following, guys? Are you following, guys? Are you following, guys? Are you following, guys? Please, I don't want to cook alone. I want to cook with you. Let's cook together. Let's cook together. Okay, so are you fine with 1.1.7? Give me a thumbs up. Give me a thumbs up so that we can move on to 1.2. Okay, there's someone who's saying is lost. Mole Mabilo. Okay, so what we are saying, Mole Mabilo, is here. Let's go back. Check here. This is the station F, ne? Station F here. Can you check station F here? Where I'm moving my cursor. 30 is the air temperature. This is the dew point. So you just subtract which one is the correct one. If you say 30 minus 6, the instruction that is given here, they are saying that if you subtract air temperature by 6, so 30 minus 6, you get 24. The dew point temperature is still 18. So if you go back here, the dew point temperature is still 18, but we have subtracted 6 from 30 to get 24. So we've got 24 and 18. That's how we got this answer here to say the answer is Z. Is it clear now? Is it clear now? Uber Broski, is it clear now? Give me a thumbs up, guys, if it's clear so that we can move on to 1.2. Molly, thank you guys, thank you guys, thank you guys, thank you guys. It's 24. This one is Z. 24 and 30. Remember, they said the air temperature decreased by 6 degrees. Tobani, are you following now? So the answer here, the dew point temperature remains 18. The only thing that is changing is the air temperature, which was 30. We have said 30 minus 6, then we got 24. So it's now 24 and 18. And there is your southwesterly wind here. Tobani, can you confirm? Can you confirm for me? You can see now. Thank you so much, guys. Thank you so much. Someone is asking, guys, we said, remember, that's why I always want us to start at the same time. Ridging is just the elongation of isobars or the high pressure system. The elongation when they are spreading towards the low pressure. Remember, our wind moved from high to low. So they are elongating, extending towards the low pressure that is in the interior. So this is your ridging. That is your ridging. Elongation of your high pressure. The isobars, they actually extend towards the low pressure. That is your ridging. Are you following? That is your ridging. So if it happens that we have got high pressure here and the other high pressure, what is in between now becomes our saddle. I think we'll get to a question with that. We'll get to a question with that. Let's just move on bit by bit. I don't want to mix a lot of things at the same time. So let's move on now now we are here now, guys. We are on this question now. That is, various options are provided as possible answers. Let me just highlight here. Various options are provided as possible answers to the following questions. All right, sharp. So what we have here, guys, let's analyze the diagram. Before we start answering the question, let's analyze the diagram. So what do we have? We have got what? A valley, okay, showing valleys in the southern hemisphere. So we have been told, guys, that this is the valley, okay, valley. All right, let me do it like this. Where? In the southern hemisphere. Southern hemisphere. Yeah, okay. So some of the things that we need to look at, number one, is we need to understand what an aspect is. Number one, what is an aspect? These are some of the things we need to understand. What is an aspect? What is an aspect? That is the first thing that we need to analyze first from this diagram. Then number two, we also need to know in the southern hemisphere which slopes receives more incoming solar radiation, which slopes are warmer. So we want to know also which slopes are warmer in the southern hemisphere. Southern hemisphere. And why? Okay, as well. Okay, so that is the question that we want. Then we can also, which slopes are colder or cooler, and also why. All right. What else can we and also why? Then from what we are seeing, which is okay, that's what we can say. Okay, so let's start with this aspect first. Someone is saying the direction in which the slope faces. So aspect is true, is the direction in which the slope faces. In which the slope faces. Okay, the slope faces. Okay, so which slope is warmer and which one is cooler in the southern hemisphere? That's what we need to talk about now. Which one is warmer? So we are saying in the southern hemisphere, I'll just say SH, a north-facing slope. North-facing. Let me just say, sorry. North-facing slope. I want to write in small letters. Sorry, guys. North-facing slope receive direct insolation, which is incoming solar radiation, hence they are warmer. North-facing slope, they receive direct incoming solar radiation, hence they are warmer. Okay. So these ones, obviously, they are cooler. Okay, this is what makes these ones to be cool now. All right, that is the south-facing slope. Okay, the slopes which are cool are the south-facing. Okay, south-facing slope, which is part of our shadow zone. Shadow zone. Are you following here, guys? So we are saying an aspect is the direction in which the slope faces. You can see our sun here, incoming rays, incoming solar radiation, okay? Insolation. So here now, it's warmer. Is the what in the southern hemisphere is the north-facing slope. They are warmer because they are receiving direct insolation. That's what makes them warmer. So in the southern hemisphere, it's just the opposite, guys. Southern hemisphere, north-facing slope are warmer. Northern hemisphere, south-facing slope are warmer. It's just the opposite. So we are saying north-facing slope are warmer and south-facing slope are cooler. So what happens now? That's why you see mostly in the shadow zone, you can see that you can have more vegetation here. Okay, you can see that let me just okay, so you can have more vegetation here. Why? Because it keeps moisture, and it's also cool. It keeps moisture. That's why you see in the south facing here more vegetation. It's likely to be dense, keeps moisture, it's more cool. That is your shadow zone, which is your south facing slope. They are not, there is reduced evaporation that is taking place. Let me put it that way. So our north facing slope, what they do is they receive direct incoming solar radiation, which makes them to be warmer. So you are likely to find sparse vegetation here. Sparse vegetation, okay? Vegetation. Why? Because there is more evaporation. More evaporation. There is more evaporation. You are likely to have more. In the north facing, this is north facing. North facing, I'll just say NF. North facing. This is what? South facing. SF. This is what? Is south facing, I'll just say SF. So, right, sharp. So this is what we have, guys. You need to know what an aspect is. Sparse vegetation, it means it's not dense. Like you have got not much vegetation, little or no vegetation. Let me put it that way. Uber, let me just say little or no vegetation. Sparse vegetation, not that much. But here is more dense. Here, the vegetation here is what? Is more denser. Here we have got a dense vegetation. Let me put it this way. Let me put it this way. Is more dense vegetation. If I put it like this, okay, dense and sparse, little or no. You understand? That's basically what this is all about. Okay, so guys, do you all understand this diagram now? Do you all understand? Are we together? So sparse vegetation, we are looking at little or no. It's not that much vegetation. Thank you so much. Uba Bronski, do you understand what I'm okay, thank you so much, guys. Thank you so much, guys. Can we move on to the question now? Can we move on to the question? Zams, what is it that you don't understand? Can you be clear? Because here I'm analyzing the diagram. We haven't started with the question. Guys, I'm teaching you this skill so that you don't rush. Ne? You understand the question first. Okay, Demon, what we are doing here is we have analyzed the diagram. We are trying to pick some information. We are linking the topic of valley climates. Let me put it that way. How are we linking it? Number one, we have said that this is a valley in the southern hemisphere. This is something that we have been told. Number one. So what comes to our mind, number one, is the issue of aspect, which is direction in which the slope faces. That is number one. So we have said this is our aspect, direction in which the slope faces. That is the definition of our aspect. That's one concept under valley climates. Number two, we need to know which slope is warmer. Is it the north facing or the south facing? And we have come to the conclusion that in the southern hemisphere, north facing slopes are warmer because they receive direct insolation. That is what makes them warmer. Then south facing slope, they retain moisture. That's why they are in the shadow zone. And there you are likely to have dense vegetation, and also they keep moisture and are cool. Can we move on to the question now? Can we get to the questions? Can we get to the questions? Thank you so much. Thank you so much. Let's go to the questions now. Sam Kelly, so what is happening? We want to start with the question. Maybe with the question you'll understand. Let's get to the questions now. Okay. So the first question is saying the relationship between slopes and the sun rays is referred to. We have already talked about this. What is it now? The relationship between the slope and the sun rays. What is it from the options given? 1.2.1, what is the answer? The relationship. What is the answer there? What is the answer? That is your aspect. We have already talked about this, guys. That is your aspect. The relationship between the slope and the sun rays is referred to is, that is insolation. It means incoming solar radiation, guys. Insolation, it just means incoming solar radiation. That's what insolation means. Incoming solar radiation. That is your insolation. Your answer there is B. Your answer is B. Your answer is B. Can we move on to 1.2.2? Okay, which is our aspect. Let's move on to 1.2.2. The surface from A to B is intensively heated because it is, okay, A to B is intensively heated because, let's just read the question again. Okay, the question is the surface A to B is intensively heated because it is, let's go back to the question. Okay, A to B. What is this? Is it receiving direct incoming sun rays? Ne? Okay, so that will be your answer there, which means our answer here is what? Our answer is C. That is our answer. Okay, let's move on to the next one. The climatological phenomena occurring at sea. The climatological phenomena occurring at sea. Yeah. What is the climatological phenomenon occurring at sea? What is the answer there? Let's go back to the diagram. Can I go back to the diagram? Climatological phenomenon occurring at sea. What is it? Here, what is it occurring at sea? Here at sea, what is it from the options given? This is where our sea is. Our sea is here. What is this? Let's go back to the question. We are doing now here. It's not terrestrial radiation. This one is out. This one is out. This one is out. Remember, the frost pockets, they happen at the bottom of the valley when the temperatures drop to below 0 degrees Celsius. Our answer there is A. Our answer is A. Remember, this is happening during the night. When you talk about advection fog, we are talking about warm air, warm, moist air moving over cold surface. So the answer there is A. Our answer is what? Is A. Our answer is A. Our answer there is radiation, which happens in cool, calm nights. That is your radiation fog. Frost pockets usually the temperatures are supposed to be below 0 degrees Celsius. That's where you have got your frost pockets. Here, your frost pockets, you can have them here. Your frost pockets, you can have them at the bottom here. Yeah. That's where you can have your frost pockets. So the answer is A there. Can we move on? A is your radiation fog. It happens in calm, clear nights because it's not happening at the bottom here. When it happens here, they have to specify that it's on the temperature is below freezing point. That's when we can have the frost pocket. That's when we can have the frost pocket. From the answers that we have, the one that is correct is the radiation fog. That's the one that is correct. Are you together, Tidiso? So that I can move on to the next one. Are we together there? All right. Sorry. I think I've moved so fast. Then can we move on? Okay, sharp. 1.2.4, dense vegetation. Dense vegetation. Remember when I was explaining, I say something in detail. Dense vegetation is due to 1.2.4. What is the correct answer there? Sorry. Oh, our answer there is what? That is your C. That is your C there. All right. Let's move on to this one now. So with this one, guys, let's analyze the diagram. Let's analyze the diagram. So the concept here, what is the concept? What is the main concept here? What is the main concept? What is the main concept? It's your what? Urban heat island. Urban heat island. That is your main concept here. Are we together? Are we together? That is your urban heat island. That is the main concept here. That is the main concept. And what is it? What is urban heat island? What is urban heat island? Can you give me the definition? Give me the definition. We are analyzing the diagram. Let's analyze the diagram. Higher temperature in urban areas. Okay, higher temperatures in urban areas than the surrounding rural areas. Okay, higher temperatures in urban areas. Okay, in urban areas than the surrounding rural areas. All right, sharp. That's correct. Forgive my spellings, please. Than the surrounding rural areas. Let me do like this. Then I'll try to. All right, so okay, let me do like this and try to take it up a bit. So this is what we are saying is the main concept here. Urban heat island, higher temperature in urban areas than the surrounding rural areas. That is the concept. So why are temperatures in urban areas higher than the rural areas? Why are temperatures? So we are saying, why are temperatures? Why are temperatures in the urban areas higher than the surrounding rural areas? What are the reasons behind the differences? What are the reasons? I want you to get help from this. The key, it can tell you something. The key can tell you something. Why are temperatures in urban areas higher than the surrounding rural areas? Okay, there's less vegetation, okay? Urban areas are high temperatures due to hard black surfaces that absorb heat fast, of course. Tall buildings, what else? Industries in urban areas, of course. All right, tall congested building, factories, and that's correct. You guys are cooking. You guys are cooking. I'm telling you. I'm telling you guys. I'm telling you guys. You are microwaving this paper. Yo. That's correct, guys. This is the reason. So you have to know. We are analyzing the diagram. We want to know why is it that in urban areas temperatures are higher than the surrounding rural areas. So the reason that you are outlining now, these are they are correct reasons. So we are looking at things such as, okay, let me just add, we are looking at industries as one of the reasons. I'm not going to write a lot. I'll just write a few. Industries, we are talking about artificial surfaces. Artificial surfaces, mostly, it's more like an umbrella term. Artificial surfaces, less vegetation, okay, less vegetation, vegetation. All right, I'll just say etc. There's a lot that you can write. Emission of gases and all those things. So this is what caused the temperatures in the urban areas to be higher than the surrounding rural areas. That's basically what we're talking about. So when you're looking at these big buildings, mostly absorption, they absorb, of course, they are pollutants that are also emitted into the atmosphere. What do? They act as a blanket, which means they do not allow the heat to escape now. That's how they result in global warming, which is more their excessive emission of carbon dioxide into the atmosphere, which results in higher temperatures. So we are saying now, that's the role that is being played by this building, by the factories, by the industries, by the artificial surfaces. But the trees now that you are finding mostly in the rural areas, they have got a cooling effect. They've got a cooling effect. That's why you see in most cases the rural areas are cooler than the urban areas. So if you look at it now, if you look at it now, your rural area, you will see them as high pressure. Okay, there's high pressure here because of the difference in temperatures. And your urban, it will give you urban area, it will give you more of a low pressure. Are you following there? I'm just adding, guys. I'm adding. I hope I'm not confusing you. We are saying high pressure because of the temperatures that are lower, cooler. Cold temperatures, high pressure. Lower temperatures, higher temperatures, of course, low pressure. Okay, so we are saying these are some of the things that result in the differences in temperatures between your urban and the surrounding rural areas. which is your urban heat island. That is the main concept. Are we together so that we can move on to the questions? Are we together? Are we together so that we can move on to the questions? Sharp, 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 sharp. If we are together, let's move on to the questions now. Sharp. Let's move on to the questions. So we are saying now, which graph below represent the change in temperatures? Take note, guys. You have to be very attentive to the detail from the rural to the urban. Which one shows the change in temperatures from the rural to the urban? Remember, in our rural is low, in our urban area is high. So which one shows? Which one shows? I want you to think again. Uba Bronski, I want you to think again. Let's think again, guys. B is correct. B is correct. B is correct. Remember, in the rural, it's low, but as you go to the urban, it's increasing. In the rural, it's low in the rural, but as you go to the urban, what happening? It's increasing. So our answer there is B, guys. Our answer is B. Remember, in the rural, it's low, it's increasing. So the one that explains the concept of urban heat island here is B. Are you following? Anyone confused? Anyone confused? Are you following? Are you following? Please don't forget to tap the screen, guys. Don't forget to tap the screen. Don't forget to tap the screen. If you are following, let's move now. Let's move. If you're following, let's move. Anyone confused? This next question reads, the reason for the change in temperature. Sorry about that. The reason for the change in temperature in the answer, the one that we have given now, is due to what could be the reasons for the change in temperature where the temperatures are high in the urban areas. From the options that we are given here, what could be in terms of surfaces? It's more what? Artificial. And there are more what? Stormy water. Okay. More stormy water in urban areas, which means our answer for 1.2.6 is what? What is the answer? 1, 2, and 3, which means our answer is what? C. Our answer is what? Is C. That is our answer there. Okay. Are we together, guys? Are we together? Are we together? 1.2.7. Let's move on to 1.2.7. 1.2.7. Okay. Let's just go here. All right. Let's. Okay. Someone is asking, why are you saying more stormy water systems in urban areas? Let's talk about the drainage system in general. Let's just simplify it. Let's talk about the way in which the water is channeled. Okay. This is the reasons for this change in temperatures, of course, due to artificial surfaces. Okay. Are you following now? Are we following, guys? Are we following? Are we following? I want us to move at the same pace. Okay, sharp. Let's do 1.2.7 now. 1.2.7. The wind direction from the rural to the urban areas is influenced by the wind direction from the rural. Wind direction from the rural to the urban is influenced by, in terms of temperature, what can we say? From the rural to urban areas is influenced by what influenced the wind direction. Remember when I was explaining here, I said rural area higher pressure, urban area what? Low pressure. So let's go back now. So our answer here would be warmer. I agree. It will be warmer here. Of course, I agree. And what else? Which means there is low pressure in the urban. So what will be your answer then? Urban low pressure. What will be the answer? 1.2.7. 1 and 4. That would be your B. That will be B here. That will be B. That is our answer. B. Cooler, remember guys, what did we say from the Nyasha? Let's go back to the concept of urban heat island. What did we say about the concept of urban heat island? Remember, we said the urban areas have got higher temperatures than the surrounding rural areas, or are warmer than the surrounding rural areas. So which one is cooler between the rural and the urban? Which one is cooler between the urban and the rural? It is the rural. Are you following? Are you following, Nyasha? Are you following, Nyasha Banks? Are you following? Yeah, you understand. So that's why we are saying warmer temperatures and low pressure in the urban areas. The fact that our urban is warmer, this is what makes them to have a low pressure. And our rural is good. The trees have got the cooling effect. That's what makes them to be more like high pressure. You understand? Which means it moves from high pressure to low pressure. That's how our wind moves. So that's what it is. Okay, let's look at the 1.2.8. The urban area will experience, what will the urban area experience now? What will the urban area experience now? What will the urban area experience? What is the correct answer? The urban area will experience, what will it experience? What is the correct answer here? More cloud cover. That's correct. There's a lot of condensation nuclei there, of course, and increase in precipitation, which means our answer here is what? Is A. Our answer is what? Is A. That is our answer then. A. Okay? So I want us to move to 2024 now. I'm starting off with the short questions. Remember, we have got 2 days for climate and weather. But I will make sure that we cover everything that is included in climate and weather. Let's move on to 2024 so that we can also look at 1.1 and 1.2. Let's move on to 2024 now. 2024 paper. All right, someone is saying, can you explain? So what we are saying, boys and girls, is, all right, let's go back. Here, what do we have? It's warmer. What do we have? This one is what? Warmer. Warm air. All right, low pressure. This one is what? Cold. Okay, it's cooler. Rural area is what? Cool. Cold air. High pressure. All right, are you following? Is it clear now, guys? I just tried to add some more. If you can go to the first thing that you started before you started climate and weather was to look at the characteristics of a high pressure system and the low pressure system. So this is basically what I'm applying here. Are you following? Someone asked me, okay, Uber Brooks, do you understand now? Please, can you give me a thumbs up? Give me a thumbs up. Give me a thumbs up. Uber Brooks, if you understand, give me a thumbs up. Give me a thumbs up. Give me a thumbs up. Danko, Danko. Let's move on to 2024 now. I want us to move to 2024 now. We are cooking climatology here, guys. And I'm doing it with you. I'm happy about that. All right, so let's look at this, guys. Please, I want you to pay attention. I want to explain first. I want you to pay attention. Do not rush to answer the questions. I want to explain first. So refer to the sketches below. Refer to the sketches below. Various options are given, of course, it's fine. Okay, no problem. So what do we have here, guys? Let's talk about this. So this is something to do with our subtropical anticyclones. Okay, let me say this is something to do with our subtropical anticyclones. Okay, something to do with our subtropical anticyclones. Okay, position. Let me say position and influence. Influence in different seasons. in different seasons. Let me put it like this. Okay, so when you're looking at these guys, this has something to do with our subtropical anticyclones, of course, position and influence in different seasons. So when you look at this number one, A, which season do you think it is? A, which season do you think it is? Season. Which season is it? A, which season is A? We have got high pressure in the interior. This is winter. This is winter. And this one, which season is it? Which season is this? This is your summer. Okay. So that's the first thing, guys. You should be able to know this is your winter, this is your summer. Why are we saying this is winter here now? That's what we want to talk about now. High pressure. Okay. Inland, which is your Kalahari high. Kalahari, which is your Kalahari high. Okay, which is your Kalahari high. What else do we have? South Atlantic high and South Indian high in the northerly position. In the northerly position. Okay, in the northerly position. That's something that you can pick there. What else do you have? Obviously, you can say the other thing that you can actually talk about is your coastal low in winter will be ahead sorry, I'm trying to, of the cold front. Okay, these are some of the things that you can actually pick. I'm just trying to, I mean, guys, I'm just trying to give you the information here. All right. Oh, no. Let me just, okay. Let me just take it up a bit. Okay. All right. All right. So this is what we are saying. High pressure inland Kalahari high. You remember during this time, that's where it's very active. Okay. It's dominating in the interior. Inland, South Atlantic and South Indian are in the northerly position. You can see where they are. They are in the northerly position. They are following the shifting of our intertropical convergence zone, which is the ITCZ. So that's what we have in A. That's what supports that this is winter. Then let's look at our summer now. There is a thermal low. There is a thermal or a heat low. There. How is it shown? We have got an L there. That is your thermal low in the interior. Let me go back here. Thermal low, inland, okay, inland. Number two, we have got South Atlantic high and South Indian high are in the what? Southerly position. They're in the southerly position. That's what you can also talk about there. Okay. They're in the southerly position. You can also talk about the region of the South Atlantic high. That's something that you can also talk about. So these are some of the things that you can see. It's the elongation of this. This is what we are calling as region. That is region. That's what we are saying is region. That's what we are saying is region, which is elongation of isobars. Okay. So they are extending towards the interior where there is a low pressure. So that is region. Okay. Region is elongation of isobars, mostly on a higher pressure. That is what region is all about. So that's what we can see here. Here we are saying now there is a thermal or a heat low, which is here, what we are seeing here. Okay. There is also South Atlantic and South Indian are in the southerly position, region of the South Atlantic. You can see both of them are actually region. You can see both of them are region. Both of them are region, elongation of isobars. They are extending towards the low pressure. That's what is happening. Okay, so that's what is happening. So do you have any question from what I've explained? Keletso, ridging, it means elongation of isobars. Elongation of isobars, mostly on a high pressure cell. That is your ridging. They are extending towards the low pressure, towards the interior. That's the ridging. That's where the ridging is taking place. Of course, they are elongated. The isobars, they are elongated. Elongation of isobars. Are we together, guys? Are we together with the explanation of the diagram? Are we together? Do we have an idea of what this is all about now? Do we have an idea of what this is all about? Mufaro, thank you. Tobani, thank you. All right, Uber, thank you so much. Okay, let's now move on to our questions now. Let's move on to our question now. Let's move on to our questions. We can always relate, guys. Sketch A shows which conditions. Sketch A, is it winter? Is it summer? Is it autumn? Mostly when it comes to the season, the most dominant, okay, season that we talk about are two, summer and winter. So what is the answer for 1.1.1? We have already explained. Remember, that's why I was explaining. So the reason why I'm showing you this approach is, guys, it saves time. When you get to the question, guys, you'll be in N1, you'll be in N4, guys. Freeway all the way. Because you already have the data. You have written your information already. You have analyzed your sketch. You have analyzed your sketch, your diagram, your infographic, whatever it is. You have already analyzed it. So you'll be on the freeway, guys. Okay, so what is the answer for 1.1.1? What will be the answer for 1.1.1? The answer there, guys, we have already talked about it. It's C. Because of the presence of our Kalahari High inland, it's more dominant. We have also talked about the positioning of our high pressure systems. All of them, they are further north, they are following the shifting of intertropical convergence zone, which is our ITCZ. Hence, they've changed their position. So that is a typical winter. You have got your coastal low ahead of the cold front. And these are some of the things that, the basic things that you should know about the winter season. These are the basic things. Okay, sharp. Let's move on to the next one. The low pressure system in sketch B forms due to this one. How does it form? It forms due to what? From the options that are given here. What is the correct answer then? Intense heating. That's correct. The answer is B there. Remember, the air above is warmed. As it is warmed, warm air by its nature is very light. So it rises. So when warm air rises, that's how a low pressure is formed. That's how our low thermal low or our heat low is formed. When the warm air rises, that's how our heat low or our thermal low is formed. So you should know the difference between your cold air is very dense, it sinks, it actually subsides. Warm air is very light. So what does it do? It rises. When it rises, that's when a thermal low or a heat low is formed. So your answer there is intense heating. Okay, sharp. What else? The next one is a concept used to describe the elongation of isobars associated with the South Atlantic in section B. What is it? We have talked about it, guys. What will be the elongation of isobars? We have talked about it, guys. You know it by now. What is the answer? Your answer there is ridging, which is C. So when we talk about baking, this is the change in wind direction here. I know some of you want to know change in wind direction. In wind direction, wind direction. All right. From clockwise to anti-clockwise. To anti-clockwise in the southern hemisphere. Southern hemisphere. That is your backing. That is your change in wind direction. Okay, from clockwise to anti-clockwise in the southern hemisphere. That is your backing. That is your backing. Your answer, yes, C. Backing. When you talk about veering, there's another concept called veering. It is the change It is the change now. It is the opposite. The change from anti-clockwise to clockwise in the northern hemisphere. That is your veering. So backing, changing wind direction from clockwise to anti-clockwise in the southern hemisphere. That is your what? That is your backing. I know some of you, you might pretend, okay, that is your backing. I'm talking about this. This is your what? Your backing. All right, that is your backing there. Sharp. All right, can we move on to 1.1.4? 1.1.4. The anticyclones in sketch A and B change their positions seasonally because of what is the answer? 1.1.4. We have already talked about it, guys. I think I've preached about it, guys. I almost speak in tongues when I was explaining this. Okay, that is your C. Shifting of the ITCZ. Shifting of the ITCZ. That is the answer there. Guys, I don't know how many times I've explained. From the first paper, I explained this in detail. That is shifting of your ITCZ. That's why we have got these things changing. This one in the north position, in summer in the south position. When our ITCZ shifts, it is what? That's how it influences the positioning of our high pressure system. Okay, let's move on to 1.1.5. 1.1.5. The South Indian anticyclone. What could be the correct answer? Let's see. South Indian anticyclone species likely to feed more moisture. Okay, what could be the reason there? I want you to think, guys. I want you to think. Stop guessing. Stop guessing. Stop guessing. Stop guessing. Stop guessing. Stop guessing. South Indian, guys. South Indian, guys. I want you to think again, guys. Let's go back. South Indian, guys. Coming. Remember, it's warm and moist. Think, guys. South Indian is warm and moist. Remember. So it has got a larger fetching distance where it can absorb more moisture. This is the same moisture now that is forced to rise on the eastern side of the moisture front. As it is forced to rise, what does it do? It condenses, clouds form. Then we have got precipitation. So the answer there is B, guys. It's B here. It's B, guys. That is the answer there. It's B. Remember, South Indian anticyclone in sketch B is likely to feed more moisture. That's what should guide you. It's likely to feed more moisture on the east coast. What happens? We have got something like this, guys. We have got something like this. Let me try to demonstrate. We have got from the South Atlantic High, we have got the southwest dry and cold from the southwest. Then we have got something, the warm and moist from the South Indian High coming towards the interior here. You understand? So it has got a larger fetching distance, where it's now absorbed more moisture. That's why we end up having the east receiving more precipitation. That's basically what you're talking about. So the answer there is what? Is B. It is a large fetching distance. Large fetching distance. That's your answer there. Here, large fetch distance. Okay. Are we together, guys? Anyone confused? Before we move on to 1.1.6. This should give you as pointers. Feed more moisture. Feed more moisture here. Feed more moisture. Where is the moisture coming from? It has got a weather area where it can absorb more moisture. That is the larger fetch. There is a larger fetch distance. That's what this is all about. Are we fine with 1.1.5? Give me a thumbs up. If you are fine with 1.1.5, give me a thumbs up. I don't want anyone to be left behind. Give me a thumbs up if you are fine with 1.1.5. Tobani, thank you. Sharp. Let's move on to 1.1.6. 1.1.6, it reads, the low pressure in sketch A will move in a, okay, the low pressure in sketch A will move in a, let's go back, that is 1.1.6. Let's go back to the diagram. In A, this one. Remember, our coastal low, it moves along the coast. Remember, it moves along the coast, which means easterly. It moves along the coast, our coastal low. That's what it does. It moves along the coast. So it's easterly. That's what it does. That is our coastal law then. It moves along the coast, which means it moves easterly. So our answer here is what? Is C. Is C. All right. 1.1.7. What do we have? The berg winds. The berg winds are most likely to develop in A because of what conditions necessitates the development of our berg winds. Okay. What do we have? What conditions do we have in A that are conducive for the development of our berg winds? What should we have in the interior? The Kalahari High. Are you following? What should we have at the coast? The coastal low. Are we together? So this is what helps our berg winds to develop. Let's go back to the question. It means, all right, we need two things here. 1.1.7. What do we need? We need our Kalahari. This one, we get it in the interior. Okay, we get this in inland. All right, inland or interior. Okay, then what we have got the coastal low at the coast. At the coast. So these are the two things that we need in order for our berg winds to develop. We need the Kalahari High in the interior and the coastal low at the coast. That's what we need. We need this. This is the Kalahari High. Kalahari High. This is our coastal low. This is our CL. Those are the two things that we need. So it means our answer there is what? Let's go back. Our answer there will be, that is 1 and 2, which is A. Are you following, guys? That is A. That is A. Our answer is A then. Are you following, guys? Are you following? Those are the two things that we need. Let's move on to, all right, let's move on to the next question. It reads, the invasion layer that forms over the escapement in sketch B will be in favor of. So we are saying now, in B, the invasion layer that forms here will be in favor of. Remember, the invasion layer will be above the escarpment. We are likely to have unstable weather conditions, especially on the eastern side. So let's go back. Let's go back. Woo-wee. So what are we likely to have here? The invasion layer over the escarpment in B. Remember, B is summer. So what are we likely to have? We are likely to have rainfall. We are likely to have hail. Okay. All this hail and your rainfall are forms of precipitation, which means your answer will be 2 and 4. That will be what? C. That will be C here. Are you following, guys? Give me a thumbs up if you don't have a problem with what we have covered. Give me a thumbs up. If you understand what we have covered so far. A thumbs up. So don't worry, guys. We are not rushing. We have got 2 days to do our climate and weather. So I just want to make sure that you understand this concept. I'm just trying to simplify them. Okay, sharp. Let's move on. Okay, we are here now. Wow. You see, we are covering everything. It's short questions, but we are covering everything. Let's analyze this, guys. Refer. Let me highlight this. Please don't rush to answer the questions. I want you to pay attention first. All right. So this is valley climates, okay? What do we have? Let's do something. What do we have here? Here we are saying this is during what? This is during the night, isn't it? This is during the night. What do we have during the night? Okay. What do we have during the night? We have what? Katabatic winds. Okay, we'll explain. Okay, katabatic winds, which are downslope winds. Okay, which are what? down slope winds. Okay. Then here on the other side, what we have? We have got, this is during the day. What do we have? We have got anabatic winds, which are what? Upslope winds. Are you following, guys? Let's start from there. So we have got katabatic and anabatic, and your anabatic are upslope winds. Then your katabatic, we are saying is what? Okay, so this is what we have so far. So we are saying now, during the night, when the earth gives off heat through terrestrial radiation, it means now the slope now is becoming colder. It cools the air above it. Since it's now cold, cold air, what does it do? Cold air is heavy. Cold air is heavy or dense. So what does it do? It subsides. It subsides or it sinks. Okay, resulting in down slope wind. That's what happens during this night. Are we following? Then during the day, what we have? We have got incoming solar radiation. So when the slope receives direct incoming solar radiation, what happens is it warms up the air above it. And as the air above it is warmed up, what does it do? It rises upslope. That's what it does. Why? Because warm air is light, so or is less dense. So as our warm air rises, our cold air subsides. That's basically what we are talking about, guys. That's basically what we are talking about. Whereas our warm air rises, our cold air subsides. Are you following here, guys? Are you following what we are talking about here, guys? Are you following? Is this clear now? If it's clear, give me a thumbs up. Give me a thumbs up, guys. Give me a thumbs up if it's clear. If it's clear, okay. If it's clear, let me try to, okay, I want to try and, all right. Let me just try to, oh, all right, I'll try to put it here, upslope. All right, let me just try to, let me see if I can be able to, all right, sharp. So here we are saying now, this also, let me just try to take it up. Ish. All right. So, guys, okay, you want me to zoom? No problem, guys. I can do that. I can do that. All right. Are you following, guys? Are you following, guys? Tell me if it's fine. So we are saying now this is during the night. Our Earth gives off heat through terrestrial radiation. So which means the slope now becomes cold. When it's cold, it cools the air above it, the slope. So it becomes colder and heavier. Dense, it starts to move down slope. That's what happens. That is downslope with katabatic winds during the night. That's why you see the arrow that is pointing downwards. During the day, we have got incoming solar radiation. It hits the slope, hits the air above it, it becomes warmer. And warm air by its nature is what? It's light, so it starts to rise upslope. So this is an upslope wind, this is a downslope wind. Are we together? It is also known as anabatic winds during the day. This is katabatic during the night. Is it clear, guys? If it's clear, give me a thumbs up. If it's clear, give me a thumbs up so that we can start with the questions. If it's clear, give me a thumbs up. I'm waiting for your confirmation, guys. Thank you. Thank you, Nyasha. Thank you. Thank you. So let's answer now. Let's answer now. So the first one is saying represents anabatic wind. Which one represents anabatic wind? Which one is the correct answer? Represents anabatic wind. Give me the answer. B. Thank you. That's correct. Then cold air forces warm air to rise, which forms an invasion layer. Which one? 1.2.2. Cold air forces warm air to rise, which forms an invasion layer. That is your A. That's correct. Your katabatic. Okay? That is your A. Then next one, occurs during the day due to insolation. What is it? 1.2.3. What is the answer? 1.2.3. Yeah, Abyss. Okay, that's correct. That is B. That is your anabatic. Okay. Then 1.2.4. Frost forms on the valley floor when the temperature drops below 0 degrees Celsius. What is the answer? 1.2.4. What is the answer? Nyasha. Okay, that's A. So I want to emphasize something, guys. Before we leave this question, I want to emphasize something, guys. All the things that we are going to talk about, things like your radiation fog. Let me radiation fog. Sorry, I want to say fog here. Your thermal belt. What else can I talk about? Frost pockets. What else can I include here? Radiation fog, thermal belt, frost pocket. All right. All these are linked. All these guys, they are linked. Ne? They are linked to the katabatic winds. That is your thermal belt, of course, form of invasion layer as well. Okay, frost pocket. All these are linked to the katabatic winds. All the concepts under your valley climates, most of them, the radiation fog, your thermal belt, invasion layer, your frost pockets, all of them are linked to the katabatic winds. So you have to know about that. Whenever they mention this, think about the katabatic winds. You have to think about the katabatic winds. They are all linked to the katabatic winds. Okay? Thank you. Someone is saying I should explain 1.2.4. So what happens with 1.2.4 now? We are saying now here is where it actually happened. You can see here. Remember, this cold air is sinking, eh? As if the cold air is sinking. Cold air is heavy. So since it's heavy as it is sinking, eh? When it reaches the bottom of the valley here, as it is sinking, you find that when the temperature drops to below 0 degrees Celsius, that's when the frost pockets are formed. That's when the frost pockets are formed. So if there is no mentioning of temperatures going below 0 degrees Celsius, you cannot have frost pockets. I don't know if you understand now, frost pockets. So we are saying now, at the bottom of the valley, when the temperature drops to below 0 degrees Celsius, that's when you can have your frost pocket. So we cannot have frost pockets if there is no mention of temperatures going below 0 degrees Celsius. Thank you so much. Thank you so much, guys. I'm proud of you. Thank you so much. Thank you so much. Let's move on. So this is what we have now. So the concept here, what is the concept? Pollution doom, guys. Pollution doom. The concept here. Pollution dome, okay. Pollution, okay. Pollution. Your pollution dome, okay. Who can tell me what a pollution dome is? Who can tell me what a pollution dome is? Can you tell me, guys, before I explain? Let's exchange. Let's exchange ideas, guys. I don't want to come here and talk until the end of the life. Let's engage, guys. I want you to benefit something, guys, so that by the end of this life, you can say, okay, I learned something today. So what is a pollution dome? What is a pollution dome? What is a pollution dome? We want to analyze this diagram, but listen. What is trapped above the seat? If you define like that, I won't give you a mark. If you just say trapped above the seat, what is trapped? Be specific. What is trapped? A trapped mass of polluted air over the seat. That's correct. Okay? Trapped. Okay. Okay, trapped what? I'm just mass of polluted Sorry, my spellings, yo. Polluted air over the city. Okay, that's correct. Or a layer of pollution of an urban area. Okay, that is your pollution dome. Okay, so from what we are looking at now, guys, this is during the day. This is during the day. And this is during the what? The night. Here is during the night. During the night. Why? There is too much subsidence here. Cold air sinking. Okay. There's too much subsidence here. There's a lot of cold air that is sinking. Okay, that's basically what we are talking about. There is a lot of cold air that is sinking. But during the day, you remember the convectional currents, of course, is more wider, it's more bigger. It's not concentrated. Here it's more concentrated because of too much subsidence that is taking place during the night. Okay. No, Matata. Is it Matata? An area of higher? No. You are defining urban heat island now. You are defining urban heat island. We are talking about the pollution dome. We are talking about the pollution dome. Please, don't confuse the two. You are defining a pollution, an urban heat island. Okay. Matata, you are defining an urban heat island. Now you are confusing the concept. Please, I don't want to give you poison. Please, you are confusing the concept there. Please. It's pollution dome, not urban heat island. You are defining urban heat island. Thank you so much, Nyasha. Please, I don't want to give you poison, guys. I don't want to give you poison. Let's be very careful. Thank you so much. Okay, sharp. So we are saying now during the night, there's too much subsidence. That's why you can see the pollutants are more concentrated closer to the surface. Why? Because during the night, there is cold air that is subsiding. That's why you see here. This is during the day. Obviously, it's more widespread. Okay, sharp. Are we fine, guys? You want to go to the question? We want to go to the question now. Are we fine? All right. What do we have? So the question now reads, this is just simple. It reads, represents pollution dome at night. Which one represents pollution dome at night? What is the correct answer? 1.2.5. What is the answer? I've said something, Demon. Okay, that is B. That is correct. That is your B there. Okay, so B, not N. All right, sharp. Pollutants are dispersed. Which one has got dispersed pollutants? 1.2.6. What is the answer? What is answer is A. There's less subsidence there. It's during the day. That's why it's more wide. Okay. Then you have got your, okay, denser concentration of pollutants over the urban area. Where is the denser concentration of pollutants over the urban area? 1.2.7. 1.2.7. What is the answer? What is the answer? That is your B. That is your B. Okay, that is your B. Okay, sharp. So are we fine here? We want to move on to the next paper. Are you seeing, guys, how we are covering a lot of concepts? We are covering a lot of topics now. If you can see from where we have started, we have covered a lot of topics now. Okay? Okay, are we fine? Can we move on to the next paper? We want to move on now to our 2025. Let's move on to 2025 now. 2025. Okay. We are moving on to 2025 now. Short questions. All right. So this is your 2025. Let me read. Climate and weather and geomorphology. We are still on climate and weather. The questions below are based on synoptic weather map. Okay? Guys, I have given you a deeper analysis of synoptic weather map interpretation. I've done that in summer, in winter, I've done that, okay, in detail. Okay, so the question that we have now, thank you, ma'am, thank you, ma'am, thank you, ma'am, for joining, thank you, ma'am, for joining. Thank you so much, ma'am, thank you so much, thank you so much. So let's move on to 1.1.1. It says, The name of the air pressure cell that dominates the interior, the name, remember guys, I've given you a deeper explanation in both winter and summer, okay? The name of the air pressure cell that dominates the interior of South Africa in winter. What is the name, guys? We have already talked about this. I think now, by now we should know, guys, because okay, that's correct. The answer there is what? It's Z. That is your Kalahari High. That's correct. Okay, let's move on now. Air movement associated with the higher pressure cell. The air movement associated with the higher pressure cell. Air movement associated with the higher pressure cell. Air movement associated with the higher pressure cell. What is the correct answer there? That is 1.1.2. 1.1.2. What is the answer? Guys, I want you to take it this way. I want you to take it this way. Remember, our air moves from high to low. Okay? It moves from high to low. Think of your subtropical high, guys. Think of your subtropical high. Subtropical high from high to low. Subtropical high towards the low, that is your equatorial. This is grade 11 stuff. So high, it actually diverges. It doesn't converge. If it's low pressure, that's where it converges. Are we together, guys? So your answer there is diverge. It diverges, which means it's from the high to the low. Think of how it moves from the subtropical high towards maybe the equatorial low, or from the subtropical high towards the subpolar low. So it's diverge. So your answer here is what? Is Z. It's Z here. It actually diverges. It doesn't converge. Low pressure is the one that is associated with what? With convergence. So your high pressure, what it does, it diverges. Okay. Are we together here? Are we together, guys? Please confirm if we are together. Anyone confused? Okay, give me a thumbs up, guys, if you understand. Give me a thumbs up. Let's move on to 1.1.3. The general direction, general direction in the movement of the coastal low system. Guys, I've already explained this. In what direction does it move? Remember when I was saying it moves along the coast. Remember when I said it moves along the coast, our coastal low. Easterly. That's correct. That's correct. Remember I said it moves along the coast, which means it's what? It's easterly. That is your Y. Okay, it moves along the coast. Okay, then this is known as the blocking high when it is in the path of mid-latitude. Okay, the blocking high when it is in the path of mid-latitude. I've already talked about this, guys. Which one is the blocking high when it is the path of the mid-latitude? Which one is it between the two? 1.1.4. That is your South Indian high, which is Y there. That is your Y. Okay. Sorry. That is your Y. Then the next one, the elongation. I explained this in detail, guys, if you still remember. Elongation of isobars extending outwards from the high pressure cell is referred to as. What is the correct answer? What is the correct answer there? Guys, I explained this in detail. What is the correct answer? That is your region, which is Z then. That is your region, which is Z. That's correct. That's correct. That's correct. That's correct. That's correct. Then is found between between two air masses of different moisture contents. Which one is it here? What is your answer? Remember, this thing happens in summer. In summer, where we have got our northeast, which is warm and moist from the South Indian high, and our cold and dry from the South Atlantic high, which means it's a moisture front. That is your moisture front, which is Y. Okay, sharp. That is Y there. It's not Z, it's Y. It's not Y. Where are you getting? We are doing 1.1.6, guys. We are doing 1.1.6. We are doing 1.1.6. Okay, sharp. Are we fine? Let's move on to 1.1.7. What is the answer? The conditions represented in the sketch below will lead to, what is the answer? 1.1.7. Your answer there is what? Line thunderstorms, which is what? Your Y. That's correct. Then the next one, it reads rainfall of 20, rainfall, I wanted to say rainfall of 20 nodes is likely to be at, what is the correct answer then? Come on guys, I want you to check here. Which one is 20 nodes between the two? This one and this one. Come on guys, which one is 20 nodes? Come on guys, you should know by now. Your weather station models, which means it's Z there. The answer is Z. Please be familiar with your weather station models. The answer is what? Is Z. Okay, the answer is Z. Okay, sharp. Let's move on. Are we fine? If we are fine with this one, give me a thumbs up. If we are fine with this one, give me a thumbs up so that we can move on to 1.2. If you are fine with this, give me a thumbs up. Okay, sharp. Let's move on to 1.2. All right, this is what we have. Hey, remember guys, we are back to that question now. Let me do like this. Okay, let me try to no, it's too much. All right, let's talk about this diagram first. I'll zoom it in. Okay, so what do we have here guys? Remember we were saying the north facing slopes. Can you check here? The north facing slope, what do we have? North facing slope, here's sparse vegetation, okay. One receives direct sunlight, you understand? Direct sunlight, there is more evaporation there, it has got less moisture, less soil moisture. Are you following? These are some of the things that guys we are picking now. Okay, let's move on the south facing slope. The south facing slope, it has got dense vegetation. Sorry, my spellings here. Dense vegetation, it retains moisture. There is less evaporation. Okay, can you pick this guys? Can you pick this from what I'm writing? Can you pick something? Guys? Are you following? Let me try to make this smaller. Okay, are you picking something from what I've been writing here? Of course, there's an issue of aspect, okay, that we can't also ignore. We have already talked about what an aspect is. Aspect is. Okay, so we are saying now, when you are looking at this, obviously it gives you an idea. Where do we have more moisture? Where do we have more vegetation? It's pointing towards where we have got more vegetation. So that already suggests to you that where there's dense vegetation is south facing slope and it retains more moisture. There's more moisture, there's less evaporation. On the other side where we do not have vegetation, obviously it becomes the north facing. Why? There's more evaporation, there's direct sunlight, it is warmer, you understand? So this one we can also add that it is warmer, okay? Okay, this one we can say, we can add that it is what? Cooler. Okay, let me just say cooler. Okay, so that's basically what we are talking about. All right, so do you understand from what I've written down? Are you picking something, guys? From what I've written down, please. I'm analyzing the picture, guys. You remember, I'm telling you, do not rush to answer the question. Understand, pick up the concept. Then you can move on to answer the question. Some of you, you just rush to answer. You understand? Sorry, yes, sorry, say, I now see. Okay, are you together? Okay, what did we say an aspect is? A aspect, of course. What did we say an aspect is? Someone is asking. We define this. What is an aspect? Okay, is correct, Keleto? What did we say aspect is? Remember, we defined this. What did we say aspect is? Come on, guys. You have forgotten already. What did we say an aspect is? What did we say an aspect is? Direction in which the slope faces. Direction in which the slope faces. Okay, thank you. That's the simplest definition. That's the simplest definition. So are you fine, guys, with what I have shown you now? Are you fine with what I've shown you now? Are you fine? Are you fine, guys, with what I've shown you now? Okay, I think you're fine. Can we go to the questions? Sharp. Let's go to the question. Okay, so the question is saying slope aspect refers to, what is the correct answer here? What is the correct answer from 1.2.1? What is the correct answer? That is your D. Thank you so much. Okay. Let me just put my D there. Okay. Then the second one is saying the photograph represents a valley. Is it in the northern or southern hemisphere? Support your answer. Is it in the northern or southern hemisphere? What is the answer? In which hemisphere is this? You want me to zoom? Okay. In which hemisphere is this? It's in the southern. That's correct. It's in the southern, which is your C. It's in the southern hemisphere. Okay, thank you. Then slope B represents, okay, slope B, what is slope B representing now? Slope B represents, so B here where we have got the trees, dense vegetation. Okay, someone is saying, can you check where your, all right, this is north facing. Okay, sharp. Can you over, first time I came when you're done? Queen B. Can you go over? It's first Queen B, what's happening? You want us to go over? All right. So this is B, of course, this side becomes your south facing. Why? Because there's more dense vegetation. It's the one that retains more moisture. On the north facing, that's where we are saying it receives more direct incoming solar radiation, which means there's more evaporation, there's less soil moisture. So the vegetation is sparse, is not doing well on the north facing, but it's more in the south facing. So that's why we come to the conclusion to say it's in the southern hemisphere. Are we together? Because north facing slope in the southern hemisphere are warmer than the south facing. That's basically what we are talking about. That's basically what we are talking about. That's basically what we are talking about. Are you following? Are you following? Are you following? Are you following? Are you following, guys? Are we together? Sharp. So Queen B, understand. Let's continue. Let's continue. All right, sure. So we are now on 1.2.3. Slope B represents, what does slope B represent now? Slope B, let's go to our slope B. What is it representing? Slope B. Remember, it's in the south facing, which is cooler and retains more moisture. Which is cooler and retains more moisture. Which means our slope B, where there's dense vegetation. So what it does, number one, it's more cooler. And what makes it more moist is because there's less evaporation. Which means our answer will be what? 1 and 3, that will be 1 and 3. What will be our answer here for 1.2.3? 1 and 3, that will be C. Okay, sharp. Are you following, guys? All right, let's move on to this one now. Guys, what we are talking about just now, guys, can you check the moon, half moon here? Already, what comes to your mind? This is night. Why? Because I am seeing the moon. We are doing this question now. We are analyzing this diagram. I'm seeing the moon here. This is night. Obviously, what comes to your mind? obviously you are going to think about what? Katabatic winds. You are going to think about what? Katabatic winds, which is also known as downslope. Downslope winds. Okay? So what else comes to your mind? Obviously, this is what should come to your mind when you see the half moon. It's night, katabatic winds, downslope winds. Are you following? Okay? Katabatic winds, downslope winds. Okay? Katabatic winds, downslope winds. You are seeing this moon here. You can see the half moon here. Obviously, that is the half moon over already. You know that this is during the night. This is during the night. Downslope winds, of course, that is your katabatic. Okay. So what concept will come to mind? Here, obviously, you can see there's likely to be agriculture taking place here. So what should come to your mind now is the frost pockets, number one. Frost pockets. So which means crops should be frost resistant if they are to be grown. They at the bottom of the valley, they're supposed to be frost resistant. That's something that should come to your mind, obviously, because you can see trees and everything look like there's farming taking place, of course. So we are saying now they should also be what? Frost pockets. That's what should come to your mind when the temperature drop to below 0 degrees Celsius. Obviously, if crops are sensitive to frost, they cannot do well at the bottom of the valley. I'm just talking in general, guys. This is just in general. Let's go to the question now. I've already said this in general. Okay, the arrows at A indicate, what does it indicate, these arrows? This is a downslope wind, which means our answer there is what? 1.2.4, what is our answer? What is our answer here? What is our answer? B. That's correct. That is correct, B. Then the main conditions for the formation of A. What are the conditions for the formation of A? 1.2.5. What are the conditions for the formation of A, which is your katabatic wind? What are the conditions? Okay, number one, this is during the night when the slope gives off heat, the earth gives off heat through terrestrial radiation. What will happen? What else do we need here? We also need what? 1.2.5. Terrestrial radiation is 1. This is during the night. What else do we need? Lower temperatures, isn't it? Remember, we are talking about what? We are talking about cold air. Cold air. We are talking about cold air sinking. Okay. Cold air. Of course, we are talking about cold air sinking. So our answer of 1 and 3, that makes it what? A. 1.2.5 is what? Is A. Sharp. All right, let's move on. 1.2.6 forms when the dew point temperature air is below freezing point on the valley floor. What is the answer here? Guys, I have preached about this. What is the answer? When the dew point temperature, what should guide you guys is here. Remember I said when you hear the mentioning of below freezing point, then what should come to your mind is, okay, below freezing point is your frost pockets, which means your answer is what? Is C. Nikki? Sorry guys. C there, 1.2.6, that's C. Sorry guys, someone was making noise. The negative physical natural impact of the answer in 1.2.6. What would be the negative physical? What would be? Oh, someone is saying I'm lost. All right. What is confusing you so that I can help? What is confusing so that I can help? There's someone who's saying, Bijana, you are saying you are lost. 1.2.6. Okay, we are saying now, no problem. We are saying now, here at the bottom of the valley, when the temperature drops to below freezing point, that's when we have got our frost pockets. That's what we are saying. So frost pockets formed when the temperature dropped to below freezing point. That's what we are saying. Okay, that's why we have said it's frost. When the temperature drops to below freezing point, that's what we are saying. Is it clear now? That's why we have said it's C. this part below freezing point on the valley floor. That's where frost pockets are formed. Is it clear now? Can you give me a thumbs up? Give me a thumbs up if it's clear. Thank you so much. Okay, sharp. Then 1.2.7, the negative, please take note, guys, is saying the negative physical, which is natural impact of the answer of the frost pocket. What will be the nation? Which means you are looking on the physical environment. That's what way you are looking at, okay? Which means your answer is what on 1.2.7? What will be your answer here? What will be your answer? That will be your D. That's correct. That will be your D. Okay, sharp. That will be your D. Okay, we are doing, can you please also explain 1.2.5? Okay, 1.2.5. No problem. 1.2.5 is saying, okay, the main conditions of the formation of wind. Okay, katabatic, okay, katabatic winds. We are saying now, during the night when the earth gives off heat through terrestrial radiation, what happens is the slope now becomes cold and it cools the air above it. You understand? And when the air above it is cold, it starts to sink or to subside, or that downslope movement. Why? Because cold air is heavy. So the one that is linked now to this katabatic wind is terrestrial radiation. You understand? Then what happens when that cold air now, low temperatures, obviously the temperatures, cold air, low temperatures. So this is during the night. It's not during the day. We are talking about the katabatic winds. So that's what is happening. So is 1.2.5 clear now? This is during the night when the earth gives off heat through terrestrial radiation. So what happens is the slope becomes cold. It cools the air above it. When it's cold, cold air is dense. It starts to sink. Cold air also has got low temperatures. It's cold. So these are the two concepts that are linked now. That's why we say it's A. The conditions for the formation of katabatic wind. Sharp. Then which other one? 1.2.7. Queen B, 1.2.7. 1.2.7, we are now saying now, on the physical, the frost pockets, we are saying now the frost pockets, they are formed when the temperature is below freezing point. What will be the effect on the natural environment? When the temperatures, remember I was talking about some of these crops or even vegetation, if they are sensitive to frost, they are bound to be affected in a way. So we are saying now it destroys vegetation. The frost pockets, what they do, they destroy vegetation. That's a natural, negative, natural impact of frost pocket from the options that are given here. Remember, it's saying the negative here. It's saying the negative. So that's why we say it destroys vegetation. This is in the natural setup, in the natural environment. So that's why we say it destroys vegetation. Is it clear now? Is it clear? If it's clear, give me a thumbs up. If it's clear, give me a thumbs up. Give me a thumbs up if it's clear. If it's clear, let's do the last one now. Then we call it a night. We are doing the last one now. Then we call it a night. Okay, sharp. This is the Gauteng Prelim for 2023. This is the last one, guys. Then we call it a night. We need about 10 to 15 minutes will be done. 10 to 15 minutes will be done. 10 to 15 minutes will be done tops. Okay. So the first question reads, of course, I'm just going to go to the straight to the question. Guys, you have got the description here. Then you've got the options that you're supposed to choose the correct answer from. Okay. So what we have refers to, we are almost done, guys. I know you are writing tomorrow. Refers to the area that does not receive, let's say, does not receive sunlight. Okay, which one is it from the options given? Which one is the correct answer? That is your shadow zone. Okay, we have already explained this, guys, in detail. All right, I want you now. Yeah. Then at night, air on the valley floor cools rapidly due to, I was talking about it just now. What is the correct answer? 1.1.2. What is the correct answer? I was talking about it just now. That is your Z, terrestrial. Okay, sharp. Then next one, if the dew point temperature is below, I was talking about it just now. If it's below freezing point, what would be the answer there? That would be your frost, ne? That would be your frost, which is Z. Okay. Then the next one, in the mountainous regions of Cape Town, people tend to build their houses on the which slope do they build their houses? Remember, Cape Town is in the southern hemisphere. So which slope is warmer? 1.1.4. Cape Town is in the southern hemisphere. Which slope is warmer? In the southern hemisphere. That is your north-facing slope, which is Y. So what they are doing, these guys, they confuse you by giving you this. You and you should know that in the southern hemisphere, north-facing slope are warmer, regardless of whatever place they are going to tell you. If that is already in your mind, then you are not going to get confused. Some of you just start thinking, oh, Cape Town, where is it? And blah, blah, blah. But it's in the southern hemisphere, north-facing slope. Then here, a warm layer of air with cold air above and below is causing invasion layer is known as, what is the correct answer here? This is straight into the point, guys. That is your thermal belt. That is your set there. That is your what? Thermal belt. Okay? That is your thermal belt, which is it. Okay? Let's move on. It's not frost pocket. And Leon, it's not frost pockets. It's what is thermal belt. Remember, we have talked about frost pockets just now. It is formed when temperatures in the valley are below the freezing point. So the answer there here on 1.1.5. 1.1.5, guys, let's not rush. Let's slow down, let's slow down, let's slow down. Otherwise, we are going to end up mixing things. So we have said 1.1.5. Are we fine with 1.1.5? So that we can move to 1.1.6. Give me a thumbs up. 1.1.5, if you are fine. I want a thumbs up. Thank you. Let's move on to 1.1.6. 1.1.6, plants that require more sunlight in winter grow best in, okay. Plants that 1.1.6 that require more sunlight in winter grow best in the northern hemisphere. In the northern, you see what they're trying to do now. You have to know, okay, 1.1.6, in the northern hemisphere, which slope is warmer? In the northern hemisphere. In the northern hemisphere, which slope is warmer? The answer here is Y. So in the northern hemisphere, south-facing slope are warmer. In the southern hemisphere, north-facing slope are warmer. That's basically what we're talking about. It's just the opposite. Master one, then you apply to the next. That's all, guys. Okay. Then the last one. The area of the valley which receives direct sunlight in winter is known as, don't worry about the winter or whatever, which receives direct sunlight. What is it called? Your answer there is what? That is your Y. That is your Y. That is your Y there. We are almost done, guys. I know you are writing tomorrow. Let's do this. We are doing the last one, 1.2. Okay, someone is, okay, let's go back. Let's go back. Someone is saying, why say? Which one are you saying? Why? Why say? Lebohang is saying, why say? Which one are you asking? Be specific. The shadow zone does not receive direct sunlight. The shadow zone does not receive direct sunlight. It is that, okay, is the zone of incidence, okay? The shadow zone, from the options given, Y is correct. Shadow zone does not receive direct sunlight. The shadow zone. Remember, in the southern hemisphere, that is the south-facing slope, which does not receive incoming solar radiation. Okay. Here is just the opposite, guys. We have said in the northern hemisphere, what we are saying now, in the northern hemisphere, south-facing slope are warmer. And in the southern hemisphere, north-facing slope are warmer. Here it is said in the northern hemisphere. In the northern hemisphere. So in the northern hemisphere, south-facing slope are warmer. Thank you so much. Thank you so much, Leohang. That's what we do here. We don't go until all of you understand. We don't rush. Okay. So can we move on to the last part now? Can we move on to the last part now? Okay. This is where we are now. What we have now. What can you see here? Let's talk about what you are seeing here. What can you see? What can you see here, guys? What can you see? I want you to tell me what you can see from what you are seeing from this, okay? What are you seeing? What are you seeing, guys? Talk to me. What are you seeing? This. What is this? Okay, I can talk about the mid latitude. Of course, I can talk about the mid latitude. I'm seeing the mid latitude there. Okay, I'm seeing the mid latitude. Okay, which happens in families, family of. Okay, which happens in family, of course. Family, of course. Which happens in families, cyclones, of course. What else can you see? I have seen the Kalahari High, of course. Kalahari High. I've seen that as well. What else are you seeing? I'm seeing also the isobars. Okay. What else can you see? There is a cold front. There is a cold front. What else can you see? There's also a warm front. Warm front. What else can you see? What else can you see? I can see stable weather conditions in the interior. Weather conditions. You can see from what we are seeing, like clear skies, you can see with using the weather station models. You can also see someone is talking about a coastal low. Of course, you can see a coastal low. What else can you see? It's likely to be a winter season. It's likely to be a winter season basing on what we are seeing here. What else? What else? What else? What else? So the reason, of course, isobars, of course, we are talking about, of course, hectopascals, of course, hectopascals, of course, or we can talk about the millibars. It's the same thing, guys. The unit of measurement of our pressure. That's why I'm saying we are seeing the isobars. You can also talk about the isobaric interval. Isobaric interval of that is 4 hectopascals or millibars, which is the different, of course, in terms of wind speed. You can also talk in terms of wind speed. Check at steep gradient, where we have got steep gradient, steep gradient, where the isobars are very close to each other. Obviously, it tells you behind a cold front there is what? Stronger winds. There's cold air, which means there we have got our steeper pressure gradient. Of course, you can also see the high pressure. Okay, here I was just trying to show you guys that you can actually pick some of these things from the diagram. That's what you need to do, guys. You don't just rush. Someone is saying summer season. Guys, how can this be summer, guys? With Kalahari being active, with all this. Okay, let's take now. Let's move on. Let's move on. All right, sharp. So the question now is saying the pressure cell labeled A is which one? Which is the pressure cell labeled A? Pressure cell labeled A, what is it? Which one is this? Pressure cell labeled A, what is it? It's the Kalahari High, isn't it? Are we together? So, which means the answer is what? Is C. Then let's move on. The direction of surface air circulation around pressure B. Okay, circulation around pressure B. The direction, okay, of air circulation around pressure cell B. Let's go to pressure cell B. What is pressure cell B? Pressure cell B, this is a South Atlantic high. This is South Atlantic high. B is what? South Atlantic high. B is what? South Atlantic high. South. Okay. And this is South Atlantic high. Atlantic high. What is the air circulation there? It's anti-clockwise. Remember, it's in the southern hemisphere. So the circulation there is what? B, anti-clockwise. Remember, high pressure cells in the southern hemisphere? No, it's not A. Clockwise is the low pressure. The high pressure is anti-clockwise. The answer there is B. Remember, guys, the high pressure system in the southern hemisphere, they move in an anti-clockwise direction. The low pressure, which is your cyclone, is clockwise. So the circulation there is anti-clockwise. 1.2.2. Are you following? Keleto, are you following? The circulation of high pressure cell. Thank you so much. Keleto, are you following? I want Keleto to confirm. Thank you so much. All right, sharp. Let's move on. Then the area of elongated high pressure at sea is a 1.2.3. Guys, this question, they like it so much. Elongated pressure at sea. This is high pressure. Elongation of air pressure, of course, of isobars at sea. What do you call it? This elongation. They are ridging. They are ridging. You understand? So what do we call it? We call it what? Ridging. So the answer is a ridge, which is what? A. We are almost done. We are almost done. Then this one now. Whether system D develops, sorry, whether system, sorry, let me try to highlight it. Whether system, okay, it doesn't want to highlight. Okay, what will be the answer there? 1.2.4. That is your A. You're right. That is your A. That is your A. That's correct. Then 1.2.5. We are almost done, guys. We are almost done, guys. The map shown above is an example of dash synoptic weather map because of what is the answer there? Remember, we have said what? It's winter. Remember, we have said that it's winter. Of course, we have said that it's winter, which means it's this one. And our winter and our mid-latitude is associated with the frontal, which means 2 and 3. That will be C. That will be C here. That will be C. Anyone confused? Remember, guys, this is winter. Ridging, it means the elongation of isobars on our high pressure cell. That is ridging. That is ridging. Ridging is the elongation of our isobars. Here, you see they're extending towards the interior where there's a low pressure. So when they are extended, that is your ridging. That is your ridging. Okay. Are you fine now? Drea, you said you wanted to know what ridging is. Elongation of our isobars towards the low pressure. That is your ridging, okay? Then this one we have said. So it means our answer, okay, that one we said is C. Are we fine with 1.2.5? 1.2.5, are we fine? Give me a thumbs up if you are fine with 1.2.5. Are we fine? Sharp. It can be conventional. Conventional, guys, come on. This is mid-latitude. In Cape Town, it rains when it is cold. So it's winter in frontal. 1.2.5 is winter in frontal rainfall. It's winter. The synoptic weather map is showing winter. And the type of rainfall is what? Frontal. It's frontal. Are we together? It's not convectional, it's frontal. Are we together, guys? We are almost done. We are almost done, guys. Okay, sharp. Let's do 1.2.6 now. Weather station D usually brings What does it bring? Weather station D usually brings what? Usually bring weather station D. What does it bring to Cape Town? Weather station D. Of course, let's go back. What does it bring? Weather station D. What does it bring? Sorry. I moved it so fast. This one. 1.2.6. Approaching cold front. What does it bring? Cold and rain. That's correct. Cold and rain, which is what? C. Cold and rain. Come on, guys. Toban. The cold front. Does it bring warm and rain? Cold and rain. Cold and rain. That's what it brings. Cold and rain. Thank you so much. This cold and rain is not B. It's not B, it's C. 1.2.6 is C. Are we together, guys? Sharp. Then 1.2.7, we want to finish now. The weather stations associated with pressure cell AR. Let's go to pressure cell AR. Pressure cell A, which is your Kalahari. What is associated with this? What happens in the interior? Remember, we've got dry conditions with clear skies. Dry conditions with clear skies, which means our answer is what? D. Our answer is what? D. That is D. Okay. Then Yamafelo now Rafetanu. 1.2.8. The pressure, okay? The pressure at the center of the pressure at the center of pressure E is, let's go to E. Let's go to the diagram. The pressure at the center of E, can you see of E? It's less than 1004. Less than. So it's less than, you can see E. It's 1004. It's less than, this is low pressure, which means the pressure increases as you go outwards, okay? So it's less. Let's just finish up. So we are saying it's lower. And what else? In what direction does it move? It's lower. In what direction? Remember, it's a coastal low. What does it move? In what direction does it move? Along the coast, which means it's lower 1 and 4. 1 and 4. Which means our answer there is what? Is B. Our answer is B. That is our answer there. No. It moved from west to east. Coastal low, it moved from west to east along the coast, not east to west. 1.2.8 is B. That is 1 and 4. It doesn't move from east to west. It moved from west to east. Are we following? Are you following? Okay, guys, I think that has taken us to the end. Tomorrow, what we are going to do tomorrow, we are continuing with our climate and weather. So what we are going to do tomorrow, obviously tomorrow, that's when we are going to do the 15 marks questions. I will make sure that I cover mid-latitudes. I'll make sure that I cover tropical cyclones. I will also make sure that I cover subtropical anticyclones, 15 marks question. I also make sure that I do questions that cover valley climates and urban climates. So tomorrow, don't worry, you are covered. Let's meet tomorrow. Let's make a date tomorrow. Same time from 8 to 10. Let's make a date tomorrow. Please, guys, subscribe to my YouTube channel. Please, you can just hit the subscription button. The link is on my bio. Please subscribe to my YouTube channel. Please, before you go, just tap the screen, guys. Just tap the screen for more likes. Thank you so much, guys. Let's meet tomorrow, guys. Tell your friends to tell your friends that tomorrow we have got another live. Okay, thank you so much, guys. Thank you so much. I really appreciate it. Thank you so much. Let's meet tomorrow, same time. Tomorrow we are doing the 15 marks question. We'll try by all means to mark everything. So tomorrow we are going to round off our climate and weather. Then on Wednesday and Thursday we'll do geomorphology. Wednesday and Thursday we'll do the live for geomorphology. Then on Saturday is just strictly GIS. On Friday we don't do anything. On Saturday is GIS. On Monday, map interpretation. This is the lineup of the lives. So tomorrow, climate and weather. We are concluding climate and weather. On Wednesday, we are starting with geomorphology. Then on Thursday, geomorphology again. Friday, we take a break. Saturday, GIS, Geographical Information Systems. Then on Monday, we will start with map interpretation. Then on Tuesday, map calculations. We are done with paper one. That's how we're going to do it. That's how we are going to do it. Thank you so much, guys. Thank you so much. Before you go, just tap on the screen, tap on the screen. So the papers that I've used, guys, I've used NSC 2023, 2024, 2025, and the Gauteng paper for 2023, the prep paper. That's what I've used. If you can check on my TikTok, I think I've shared the papers that I'm using. If it's possible, guys, download those papers so that when we are going through these questions, you can understand what exactly we are reading and also the way we are answering this question. Thank you so much, guys. Please share my my link for my YouTube channel with your classmates, please. I want as many subscribers as possible for my YouTube channel. Please, guys, please, 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 for my YouTube channel. For my YouTube channel, I beg you guys, please just share with your classmates, with your friends, everyone, so that they can subscribe. It's just, you are not paying anything. You just subscribe. You just click on the subscription button. Okay. Thank you so much, guys. Have a blessed evening. Thank you so much. Good night. Yeah. I didn't stop it.